Okay, so in this video, I just want to practice doing some of the derivatives. And, one, just so we can practice using or starting to learn and recognize what are the derivatives of these inverse trig functions. But then also, two, to kind of practice and see some examples of you're going to have chain rule, most likely. You're not going to just have arc cosine of x. In this case, it's arc cosine of 2x cubed. What you want to focus on is that whatever this is in terms of your ratio that you're putting into this arc cosine, that is what they are using as a placeholder up here as your x. So if I erase this much here for a second, and if I think about, okay, so here, whatever this value is, that's what's being squared, no matter what that is. So in my example, my value I'm putting into that function is 2x cubed as a quantity. So let's go ahead and do this example. So the derivative of arc cosine, remember all the cos are negative, so it's negative 1 over the square root of 1 minus that quantity, so 2x cubed squared. But then immediately after that, I have a chain rule, the derivative of 2x cubed. The derivative of 2x cubed is 6x squared. So that would be multiplied by that negative 6, so I could rewrite this as negative 6x squared over the square root of 1 minus, and I'll go ahead and expand that out, that's 4x to the 6th power. So hopefully, okay, but again, knowing the structure of what does arc cosine look like. Okay? Arc secant, again, just like the previous example, whatever's in here is the x that the definition is referring to. So when I have the x out here, I have two places, for secant, same for cosecant, but for secant, I have wherever that x is there, I take its absolute value, and then on the inside, I square it. So I have to make sure that I'm doing that for both, both locations. So let's go ahead and do this one. This one, maybe we'll do this one in red. Maybe, there you go. So we get 1 over absolute value of 5x times the square root of quantity 5x squared minus 1. Immediately after, derivative of 5x, which is 5. Now 5 obviously is positive, and in this absolute value, this 5 as a positive number could be factored out, so I can actually cancel those. This 5 can actually cancel with that 5, but I have to keep that x in absolute value. So then my final simplified answer I could write as 1 over absolute value of x times the square root of 25x squared minus 1. Next example, arc sine. Okay? And again, arc sine of root x. So this is telling me that this is my ratio, that's what's in the definition. So when I do the derivative, 1 over the square root of 1 minus that thing, in this case root x squared, which is actually pretty nice. But then don't forget chain rule. The derivative of root x, which is 1 over 2 root x. So I'll want to make sure I remember to bring this 2 out in front, and the root x out in front. Just I think it keeps things a little bit more simple. Times, this is actually very nice, the square root of 1 minus x, all in the root. Now whether you leave this root x out here, or if you want to combine those since they're both both square roots, it's up to you. I'm going to leave it just like that. Okay, so let's do example 6 here next, just to kind of see where we're at. We've already seen arc secant, maybe a little bit apprehensive, maybe not, about the e to the x, but every place in the derivatives definition of arc secant, if there's an x here, we replace that with e to the x. So they just follow from there. 1 over absolute value of e to the x square root of e to the x as a quantity squared minus 1. Chain rule, derivative of e to the x, which is itself e to the x. Now, I actually picked this example on purpose because e to the x is always a positive function. The absolute value bars are redundant. So I really don't need them, and then that makes this e to the x cancel with that e to the x, which simplifies this to just 1 over the square root of e to the 2x, because that's e to the x squared minus 1. So then, and we'll, I'll solve the other examples in the next video, but certainly try them, try all of them, check your answers, check the solutions that are posted on Canvas.